So today we're going to be looking at the area of a sector. So let's draw our, get my pen the right colour or you won't see it because pink on pink doesn't work. So, not plugged in my tablet to drive with, won't work. Here we go, there we go. So let's draw a circle. And the centre is O, and we've got some angle theta, we've got A, and we've got B, and it's a radius of R. So let's find the formula for the area of this sector. So let's consider the area of it, we're going to look at the ratios, area of a sector over the whole area of the circle, which is pi r squared. Because the area of a sector is part of a circle, if we take the area of the circle over the area of the sector over the area of the whole circle and divide it by the angle of the sector over, now the angle of the whole circle is 2 pi. It's the 360 degrees. Now, we can rearrange this. Of sector is what we want. Pi over, pi r squared is the circle. Then we've got theta over 2 pi. Rearranging that, the area of a sector equals half pi, half theta r squared, because the pi's are going to cancel themselves out. And this is a general formula. Oops. Now let's look at some examples. So we want to find the area of a sector for a circle with radius 9 centimeters and the sector's angle is pi over 6 radians. So the area of the sector equals a half r squared theta, and that's equal to half 9 squared pi over 6. So if we work that out, so it's going to be 18. 18 divided by 6 is 3. Oh no, it's not. Sorry, it's not. It's 81. So we've got a 12 here over 81 pi, and that then equals, that can be simplified down to 27 pi over 4 centimeters squared. So let's look at another example. The circle has a radius of 6 centimeters and centers 0. AB is a chord and angle AOB equals 1.2 radians. So let's draw this. So we've got AB here. We've got the centre here. And this is 6 centimetres, and this is 6 centimetres. Firstly, we want to find the area of the sector AOB. So that's going to be half r squared theta. So it's half r squared, which is 6 squared, and theta is 1.2. So that will give us, working all that out, we'll get 21.6 centimetres squared. Okay, next thing we want to do is we want to find the area of the triangle AOB. So to do that, we're going to use the sine, the formula with the sine of the angle to do this. So sine half AB sine C would give us the area of the triangle. So it's half. Now AB is both 6, so it's going to be 6 times sine of 1.2, and that's going to give us 16.8 centimetres squared. Therefore, so we're going to shade this part in here, and we want to find the shaded area. So that's going to be the area of the sector minus area of the triangle, which is 21.6 minus 16.8, which equals 4.82 centimetres squared. Now we're going to do another problem which is quite a bit more tricky, and it'll take a lot of thinking. But with things like this, the more practice you get with the types of questions that come up in exams, the more confident you would become, because the same sorts of questions are always recycled. So lots of practice and you should be able to master them. So the diagram shows a circle inscribed inside a square of length 10 centimetres. A quarter circle with radius 10 centimetres is drawn, with the vertex of the square as centre. Find the shaded area. So let's draw this. This is what we've been shown. So we've got a square, and inside the square is a circle, and inside this is a quarter circle, and we want this area. Now I'm going to draw this a bit bigger because I'm going to put lots of detailing on it. Now, centre is going to be here. Now we know this is 10 centimetres. And we've got another circle. So this is our circle, and now we've got another circle coming. And if you can imagine, it's got a radius of 10, and think of a big circle that would go round, and we've only got a quarter of it inside our box. And I'm going to change the colour of my pen so that the shading is not as... So we've got this shaded area here. Now, what we want to think about is, if this is the centre of our circle, now if we think about here to here, so if we think about our circle, this small circle inside the box, here's the centre, and if we come to here, we've got this sector here. Okay, so that sector I've just drawn, came out here, this is from the centre to here, and it kind of goes all around to that sector that I've just drawn. Now, because this is the radius, it comes from the centre to here, the radius of this circle is 5 centimetres, and that will also be 5 centimetres. Now, if we think about our, we come down to here, this is the origin of the big circle that we've got a quarter of. Now the radius of the big circle comes to here. Now we've been told that this circle has a radius of 10. Now we're paying attention, so that's 10 as well. So at this point and this point, the two circles are meeting, the edges of the two circles meet. Now the first thing we want to do is O, and this is we're going to call this bit Q, and we're going to call this bit here P. They're both 10. Now we want to find first what is the diagonal here. What's this length here? Now if we think about it, this length here, so let's think, I'm going to draw the wee box down here. That's 10. That's 10. We've got a right angled triangle with the diagonal, and that point is in the centre. So we can find the distance from this point to the side of our box, is O, by using Pythagoras. So, Pythagoras. From this origin to the edge is going to be half the diagonal, which is going to be half of the square root of 10 squared plus 10 squared, because 10 squared plus 10 squared is square root. So that's going to be half 200. Now I'm going to write this as a third, just because it'll look a lot tidier than having a big decimal. So that's like 100 times 2. The square root of 100 is 10. Half of 10 is 5. And then we've still got our square root of 2. And that is centimetres. So this here is 5 square root 2 centimetres. Now, I'm going to call this angle here alpha, and I'm going to call this alpha because they're going to be the same, because this triangle and that triangle are identical. So we can use the cosine rule. To find alpha. I'm just going to put the numbers in. Cosine alpha equals 5 squared plus 5 root 2 squared minus 10 squared all over 2 times 5 times 5 square root 2. Working all that out, alpha comes out as 1.932 radians. Now, because this is a circle, we need to find out what this angle here would be. So this angle here is this angle here is going to be beta. So if you think about beta plus alpha is going to be 360. So beta must be 360 minus 2 alpha. So beta is going to be 2.4189 radians. Now, we also want to find out the size of this angle here for the sector of the big triangle. So we're going to think about this triangle here. We'll take this triangle out here and we'll call this theta, so this will be theta. This will also be theta because it's the same. And we've got alpha up here, we've got 5 here, we've got 5 root 2 here, and we've got 10. So this is the triangle we've got in here, and we can use this to find theta. So we're going to use the sine rule. So sine theta over 5 must be equal to sine alpha over 10. Working this out, we're going to get theta equals 0.4867 radians. So therefore the shaded area must be equal to the sector for our small triangle. So we're going to call this P, Q, R. This sector here minus the sector for O, P, Q. So the sector for this minus but we need to get rid of, if you think about it, we need to get rid of these triangles as well. So the triangles in the middle. So we're going to get equal to half. I'm running out of space. I'll bring a new we'll use a rubber and I'll get rid of this. No longer need that there. Okay. So the area of sector equals half theta r squared. So we'll get half times beta, because it's this angle, times 5 squared. So that's this angle. Then we're going to minus this big sector here, so I'll draw the bit that we're minusing next. So we need to take away all of this. So that is going to be half, so it's 2 theta times 2 theta, because it's not just 1 theta, times 10 squared. But think about this. This bit here, this bit, and this bit also need to come away. So when we found this bit here is this sector here. But the only part of this sector, this green turquoise sector, that actually is going to be taken away from it is the bit that's round here. This bit. So this is where the two sectors actually interact. So we need to take this triangle and this triangle away from this big sector in order for it to work. So let's take away, we're going to use the area of a triangle from using the sine. So it's half. Now because they're identical, we can use 10, use 10 times 10 squared times sine 2 theta. And then we're going to get, working all this out, we get 14.6 centimeters squared as our answer. So hope that helps.